Okay. Represent discrete probability distributions in tables. Tables. Alright. I'm going to flip 3 coins. These coins aren't trick coins or anything, they're either going to come up heads or tails, and if it lands on its side out of a freak, we're just going to flip it again until we've got 3 outcomes. Cool. What could happen?
Heads or tails?
Is that it?
Heads, tails.
Heads.
Right. I've got 3 different coins, so just saying heads, tails doesn't encapsulate all possibilities. Okay, so in total, how many outcomes do I have?
8.
8, okay. Are we happy with 8?
Sure.
Do you have any idea why?
2 times 2.
Right, 2 times 2 times 2, right? First one, heads, tails, the next one, heads, tails, the next one, heads, tails, so I could branch 2 to the power 3. Okay, great. Well, I could write that, but everything would be a probability of 1/8. That's very boring. Do I, if we're having a game and it's first 2 wins or something, do I actually care? Sorry, let me rephrase that. Is there a difference between heads, tails, heads, and heads, heads, tails? If I care about best of 3, I should have said.
Yes.
Why?
Because heads means you don't have to roll the third one if you already got 2.
Okay, fair point. Let's assume that we want to know how badly we win or lose. So heads, heads, heads is morally superior to heads, heads, tails. Okay? So do we care about the difference between heads, heads, tails and heads, heads, heads? Or heads, tails, heads for that matter? Or tails, heads, heads?
No.
No, right? It makes no difference to us because all we care about is the total number of everything. So what we want to do is distill down from the 8 into just the individual things that actually matter. So what are the individual things that actually matter? Or alternatively, another way of thinking about it is rather than going 1, that's a head, 2, that's a head, 3, that's a tail. Rather than doing that, I get 3 separate coins and just flip them all once. So I don't care what order they come out in. How many options are there now? 4, okay. What are they?
3 heads, 2 heads, 1 head, no heads.
Perfect. Okay. So, out of interest, I'm going to start with 0. So, 0 heads, 1 head, 2 head, 3 head. Cool, cool. Or just as easily, I could have written this as 3 tails, 2 tails, 1 tail, 0 tails. Right. It's arbitrary that I've picked heads over tails. Cool, okay. What's the probability of each of those? 1 in
16.
how many options did we say there were originally?
8.
8.
Oh my bad.
There you go. Yep. Okay. This is 3 and 8. How do you know it's 3 and 8?
Well, I worked out because 0 heads and 3 heads are both 1 and 8.
Oh, okay. Yep.
And the chances of having there being 2 heads and the chances of there being 2 tails are the same.
Okay.
So then cut the 6 days in half.
Okay, fair enough. What if there was 5 coins? Is that method still going to work?
Not so much.
Not so much. Okay, so we need a method that generalizes a bit better. So let's just think about it for a second. How many coins am I flipping? 3. How many of them do I want to be heads?
1.
So how many ways could that possibly happen? 3 ways, right? Either first or second or third.
Yeah.
Cool, so 3 out of the 8 ways. Similar story with that. You could count the 2 heads, or alternatively you go, hang on, there's just 1 tail. So it's still, there's only 3 spots for the tail. Cool, so you want to be switching things to make life easy for you. Beautiful. So this is what we call a probability density distribution, or just probability distribution. There's a slight extra fiddly thing. So, down in this line, okay, this is obviously a probability of some sort. What's it the probability of?
Probability 0.
Right, it's the probability of whatever it is above it.
Yeah.
Yeah? So this is the probability of this happening. This is the probability of that happening, so on. Okay. Well, what we need is a name for this. Now, because it's math, guess what name we're going to pick?
X.
Right. Now, a lowercase x usually is a variable, right? What we're going to do is make it a capital X for when it's a probability, a probabilistic event. So, this is X. Okay, so capital X, that's that, alright. And then, sorry. This is capital X. This is lowercase x. Got that right the right way? Yeah. So, this is the distributor, so the actual thing that encompasses all things that can happen. This is just a list of all of the events that make up that entire event. So all of the outcomes that make up that event. So this guy is going to be the probability that our random thing actually turns into whatever that thing was. Cool. So capital X is all the possible, lowercase x is a specific. Are we happy with that? Yeah? Beautiful. Let's do, what was the other thing I wanted to do? I had something else and I've forgotten already. Good. What was it? Cool. Something else. So, variable y, I'm rolling 2d6, so 2 6-sided dice, and I'm going to sum the result, so what you normally do. Cool, I want to write out a probability distribution. How might I do this? Lowercase x.
3, 4, 5, 6,
Y. Lowercase y, right? You've named it capital Y. So, lowercase y. Yep.
And then 2, 3, 4, 5,
Cool, alright, start at 2. Why are you starting at 2?
Because you can't get 1 or 2 dice.
So there you go. 6. Got a bit bigger than I wanted it to, but it's okay. Cool, alright. Did I not do 12? No, I didn't. Jeez.
Oh.
Thank you. Cool. Alright. And then,
Probability of capital Y equaling lowercase x.
lowercase
Y, sorry.
y, there you go. Cool, these guys should always match letters for you guys. You can do things where they're a bit more complicated, but you will.
Is it out of 36?
Right, out of 36, why?
Because you're multiplying the chances together. So 1 in 6 times 1 in 6.
Cool.
2
1 out of 36, because 1 in 6 times 1 in 6. Alright? What about 3?
You can get 1 in 2.
2 in 36.
3.
2 out of 36, true.
1 in 18.
So 1 in 18. Okay? Right, because we can get a 1 and a 2, or a 2 and a 1, because those are distinct ideas.
So that's also 1 of 18.
How do I get a 4?
1 and 3, 2 and 2.
And 3 and 1.
1.
Right, so I've got 3 options there. Okay,
Yeah.
3 out of this, 1 out of 12.
Yeah.
How about 1?
1 and 4, 4 and 1. Wait, 1 and 4, 4 and 1. 2 and 3, 22. 4.
Cool.
That's 1 over 9.
Yep.
5.
5 out of 36? Yep.
And then it's 1 and 9, 1 and 12, 1 and 18.
Oh, no. You jumped the gun.
Down. 1 and 6.
Right, 1 and 6.
And then it's 5 and 36.
Right, and then it's symmetric. How do you know it's symmetric?
So I'm absolute genius. Because you're just leaving out, you're changing the thing as, like, what you did with heads and tails.
There's a bunch of different ways. If you draw out the grid, the 6x6 grid, you'll notice that all you're doing is counting the corner, then the next 2, then the next 3, then the next 4, then the next 5. It maxes out at 6 and then goes back to 5, 4, 3, 2, 1. But there's a bunch of different ways you can do it. Cool. Okay, what should happen with all the blues? Right, they should add up to 1. Right, so whenever you're unsure if you've done something right or wrong, just make sure your bottom thing adds up to 1. Yep, okay. What does that say?
Probability of capital Y being greater than 5.
Okay, that's literally what it says. What does it mean?
That you roll the 2 dice and the sum is greater than 5.
Okay?
Oh.
No?
I'm looking at the capital on the last thing we did. I think that adds up to 36 out of 36.
This does or does not?
I don't think it does.
You don't think it does, alright?
Are you counting the ones or are you counting them as
So that's 1, so
2,
that's 2 out of 36.
3?
3, 4, 5, 6, 5.
Oh, 1 out of 6, I lost 1 out of 36, never mind.
Okay, all good?
Yeah.
Beautiful. Alright. So, using in black down the bottom, it literally says y greater than 5. What does that actually mean?
You roll 2 dice, the sum will be greater than 5.
Right, roll 2 dice, the sum's greater than 5. Cool. How might I go about figuring that out?
Maybe get the probability of getting from 2 to 5.
Say that again, get
So
the probability of...
from landing a sum of 2 to 5. If you get the sum of that, then you can just subtract.
Oh, okay, good. So you're even dodging the hard way. Right, okay, so the most naive way would be, alright, so that's 6 or higher, so I should just add up all these fractions. Okay, well, could do that, and that would work. It's a little bit taxing. So what Rada just said, well, hang on, that's the same as 1 minus the probability of y being less than or equal to 5. You happy about that? Cool, alright. Which we can then calculate through, whatever we've got, 1, 2, 3, 4 of them. So, what's that, 10 out of 36?
5 on anything. So the probability that y will be greater than 5 is 13 on 18.
Perfect. Cool, cool. Alright. And then you can all ask all sorts of complicated variants of that. Do we want to do... What's the most complicated thing this gets to? Give that back. No, just don't give them much. Especially for crap. What does the math say?
Yeah, that's saying is y, the probability of y is greater than 7 given y is less than 10.
Right.
I can't remember the equation for that.
Don't even worry about the equation just yet. So, what is this saying happens?
If y is less than 10, what are the chances that it's also going to be greater than 7?
Perfect.
So
Okay.
8 and 9, what are the chances that y is going to be 8 or 9?
Right. Given.
Given that 10 and 7 already happened.
Almost, you were so close.
But 10.
Okay. So, let's say this bit is that, right? Because it was strictly less than.
Yeah.
That bit is wherever it was it 7? In fact,
Less than 7. Greater than 7. I don't know.
Greater than 7.
Sorry.
8 and 9.
okay. So, what's the probability of landing green given we're somewhere in the red?
So,
So, in other words, what's the probability we roll an 8 or a 9 given we've rolled a 2 through to 9? Happy about that?
yeah.
Cool. Who we? Hopefully this is a little bit familiar. If we say, we'll put it over here, probability A given B equals probability of A intersect B divided by probability B. Cool.
Yeah.
Alright. Cool. That's where they overlap, so that's where they intersect. So I've got 8 or 9, so whatever that is, 9 out of 36 over. Given from 2 through to 9.
Can't you simplify that?
So,
Do you know what to simplify that first?
okay, we'll simplify it first and then we'll see what happens. So that's 1/4.
That just becomes 9 on 30.
That's 5/6.
That's 3 on 10.
Alright, is that nice to work with?
No, it's not.
Not particularly. Is this nicer to work with?
Yeah.
Yeah, right. Why?
Because the 36s cancel each other out.
Gotta love that. Alright. Whenever you're doing your calculations, commonly it's a good idea, leave it in whatever the biggest denominator was, because then it'll cancel out with the other biggest denominator, and that knocks out heaps of factors straight away.
Yeah. So,
Don't have to, but cool. So we end up with 9 on 30. Much simplified.
Right.
3 on 10. Fully? Happy? Beautiful. That's about as complicated as that gets. Alright, it's just a way of representing things so that you don't have to draw out massive tables or massive trees. You just think about it and go, hang on, these are the only outcomes I actually care about. How many ways are there of getting each? Yeah, we'll do that again. I'm going to make that one, I'll just move over on this side. Okay, cool. New scenario. There are 12 marbles. You're going to pick out 3.
Okay.
And I should have written that. Pick 3. Like randomly, unsurprisingly. There are 5 reds in there, 4 blues, and 3 greens. Okay. And for the sake of argument, I'm going to say you just put your hand in, pick up 3, pull them out, and go, that's what I got.
cool.
Do I, how many, if I went 1, 2, 3, alright, how many possible outcomes do I have?
Is it 60?
Not much.
Okay, well let's go back the other way. Let's say that all of the things also have numbers on them. So it's red 1, red 2, red 3, red 4, red 5, blue 1, 2, 3, 4, green 1, 2, 3. Alright, so as I pick them out, I know, I pick it out, I go green 2, blue 3, red 1.
And then make it 60.
12 times 11 times 10.
Right, 12 times 11 times 10 would be that.
That's not right, it's not like it, okay.
Because I've got 3 spaces and I'm going to fill them. 1 out of the 12, there's only 11 left. 1 out of the 11, only 10 left. 1 out of the 10.
Yeah.
Yeah? No? Yeah?
Yep.
Yep? Okay.
So,
So, 12 times 11 times 10, that's a lot of things. I don't want to write all those. So, we go back. There are no numbers on it. Now how many options do I have?
Wouldn't that be 12 potentially
That'd be even bigger than what we had before.
Is it like 60 over like, I don't know, 12 dimensions, 12 days?
6 exponentials, 7 exponentials.
Okay. Might we need to structure our thoughts somewhat at this point?
probably.
Yeah, even,
Okay. How many options do you have for the first?
3.
3 options. It's either red, or it's blue, or it's green. How many options do you have for the second? 3. It's either red, or it's blue, or it's green. How many do you have for the third?
3.
So how many overall?
9. 9. Because 3 times 3 times 3 divided by 3.
Why are you dividing by 3?
Piece of power. Why not?
27?
27. 3 times 3 times 3.
No, Dean.
But I'm right, you're wrong, so shut up.
If you just divide it by 3, it's 9.
That's
Okay,
cool.
So, and just to be clear, I'm defining red, blue, green to be different
Why
to
don't we
green,
divide
blue,
by
red.
Why don't we divide it by 9?
Stop talking. See, Dean's on it.
Why don't you just divide by 27?
It's
That's
actually 3.
Why don't you just divide by 0 and then we're done? Okay, so we've got 27 total possible arrangements. Okay, great. Are each of those 27 arrangements distinguishable from the original scenario set out, which was grab 3 and put them down?
No, because it's
No. How many distinguishable arrangements are there?
3. Oh, no, 9, right? 2027. Turns out I don't know.
Okay. Let's start a systematic way then, if we're stuck. What's the most straightforward starting example?
Green, green, and green.
Green, green, green. Okay, we'll start that. Fine. Green, green, green. Okay, what's the next?
Green, green, red.
Green, green, red. Okay, fine. I don't know why we're going. Can we go green, green, blue, please? Just so that we're at least going in one order or the other.
I don't want to. We're going to go from top to the bottom sometimes, you know?
Top to bottom's fine, bottom to top's fine. I'm saying just going bottom to top to middle is weird. So I've got bottom, middle, top. Okay,
It's
fine.
so weird because
What's the next?
So you're saying green, blue, green is the same as that as well, yeah?
Okay. Yeah. Yes.
Yeah, you're taking them all out, yeah. So then it'd be green, blue, green, green, red.
Okay, green, green, red.
And then you can go, what, blue, blue, blue?
You
Oh,
can.
no, green, green, blue,
You can,
blue.
but that'd be stupid.
Sorry, yeah, green, blue, blue. And green, blue, red. And then,
Do we have to do all these?
no,
No, that's kind of the point.
Why are we
and
just
then
trying to
it's
throw
green,
it?
red, red.
We want that, yes, we want that.
And then, surely you just times 11, 3. Times all of those with also 3.
I mean, why wouldn't you do green, red, blue?
Because it's the same as green, blue, red.
That's true.
Okay.
Oh, see, I'm right, you're wrong now this time, aren't
Yeah.
Are there any other ways to smuggle a green?
you can take it out completely. You could get red, blue.
Yeah,
So there's no green in there.
Yeah.
Yeah, okay,
We
right.
can't smoke green in there.
Let's go to the next thing, and I'm going to start with a blue.
Blue,
What's the
blue.
most?
Why'd you put a cap there? Is that like significant?
Just to say I've stopped with the greens. That's all.
Okay.
Okay, true or blue? What else can you have?
Blue, green.
Red.
Can you have blue, blue, green?
Oh, actually, very done.
Blue, blue, red makes sense. Okay.
That's about it.
Oh, okay, so you're meant to do this twice.
What else you got? Oh, is there anything else?
That's
red,
red.
And then.
Oh,
Oh, I'm smart.
Okay.
So there's 10 options.
Okay, so 10 distinguishable things.
Oh, because 5 plus 4 plus 3 is 10 when you minus 2.
Yeah.
You're wrong, but that's a bit.
I mean, maybe, but I don't see how that's relevant.
It just doesn't make sense.
Okay,
See, if TJ was here, he would agree.
I'm sure he would.
I miss
That doesn't mean
TJ.
much. If anything, that weakens your case.
Riley,
Okay.
can you give one TJ?
I might have to do that.
How many ways can green, green, green happen?
Lot.
Once.
That's a lot.
I can also happen once because. Why not?
Oh, we can
Because
get on
that-
different spots.
Right.
But you said that doesn't matter.
I agree that I said it doesn't matter, but how many ways
Now it
could
matters.
we get some iteration of that where we couldn't tell the difference?
Well, I don't care because it doesn't matter.
3 for the next one.
3 because the blue can shift places.
The
And
red.
3 again.
And then 3 again.
Lovely.
And then 3.
Okay, I've got 3 and I've got 6.
Well,
I
Middle
disagree
point,
with
4.5.
Dean, so that leaves with 6.
Say
what
again.
would that look like?
I said I refuse to agree with Dean, so I therefore say 6.
That might be a pretty good policy in general.
I failed.
So, one way to think about this, I've got 3 distinct items in 3 distinct places.
3 times 2 times 1.
So,
Oh, nice.
See?
Well, they're wrong.
you've got 3 distinct items to put in 3 distinct places. So you've got 3 things to put in the first place, then 2 to put in what's left over, and then 1 to put in what's left over.
That's
3 by 2.
right. Stop being right.
Okay.
3. 1, 3, 3, 1. Just pass.
Great.
I'm passing all my tests.
Is that currently all that useful, the way that's set up?
No, because what does that mean? What do we do with them?
Something.
What do we need to do with them?
We can do things.
I don't really know.
Oh.
Nice if it was a
We're
text.
actually drawing a graph, guys. I thought we were for a second.
9, 10.
This is how trigonometry correlates with probability.
This isn't even true.
I was joking.
Well, every month that by 3.
9, 10, nice. Okay.
I lost count.
Now, do I want to write GGG?
No,
Yes.
not really.
What would you prefer to write?
G3.
G.
I'm going to go 3G rather than G3.
I was going to say G cubed.
Cool.
Because our brain was.
Next option?
2GB. 1B, sorry,
It's
yeah.
even harder to write.
I mean, the one's silent though.
Alternately, you can write these as powers and things, but I think this is a bit more intuitive.
Makes sense.
That's a 1, not a 9. Typically. Cool. This guy?
2G,
1.
2B, 1G, I guess. Just keep like,
Cheeseburger?
well, do you want G at the front?
I'm going to
I like the
G at the front because it's a bit more systematic, but you could do it the other way.
I just like the numbers going from biggest to smallest.
Draw.
And then you've got 1G, B, 1B, 1R.
I'm going to write that as 1EA. Do we know what EA is short for?
Each. Oh, EA Sports.
EA Sports.
That's it.
One rip-off.
That's E.
Cool. And so.
1G, 2R,
Someone wants you.
3B, 2B, 1R,
It's just a game.
1B, 2R,
It's in the game.
and then 3R.
Math is a game that EA is in.
What is the underneath?
Oh yeah.
Okay, so what did we do with our other tables?
We've numbered them.
I'm going to choose.
Probability,
I'm going to choose this thing because we're dealing with marbles to be capitalized.
Matter.
sorry.
So what have I got on this?
Lowercase
Lowercase m on top.
Yeah.
And
I like
Yeah.
per color.
probability.
PR,
I like it cut G.
Cool. All right. What are my probabilities to fill in?
is it 1 in 10?
1
This
out.
one? Is it there, like right out of 10?
Why 10?
Because I really just want it to be 10. But because there's 10 possibilities and order doesn't matter.
I agree that there are 10 distinct possibilities, but are they all equally probable?
Nope.
Nope. 1 in 27. How do you
Oh,
know?
yeah.
27? We thought we worked that out before, right? Now, at this point, what should we probably check?
The 27 is the right answer, because I don't know, you're a bit
How are you
stingy.
going to do that?
I don't know.
Say again?
They all add up to 27.
Right, all these should add up to 27.
Oh, yes, I agree.
1, 4, 7, 10,
Four.
16, 19, 20,
Well, yeah, 1, 2, 3,
27.
4, 5, 6, 7, 8. So 18, 18, 19, 20, 21, 21. You missed
Solid
one.
effort.
You missed something.
I missed the 6. This makes sense.
1, 2, 3, 4, 5, 6, 7, 8. 8 plus 3, 18. 9, 20, 21. I missed.
No, you're miscounting. I think you're miscounting. Count all the 3s.
Yeah. 1,
3,
2,
6, 9,
3,
12,
4,
15,
5, 6.
18. And then count the 2 1s, 20. But then count the 6
And
and
then
then
the
the 1s.
ones is 9. 9 times 3 is
4.
27.
I just counted downwards. 1, 4, 7, 10, 16, 19, 20.
Yeah, 27. What am I doing?
Oh.
Not
Oh, I didn't.
math.
Oh.
It's divided by 6.
3, 6, 9, 12, 15, 18, 20, 26, 27.
Yeah, that's fine.
It's divided by
I did
minus
the
6.
same error 2 or 3 times. I don't know how I did that, but good job, man. Anyway.
What's time for
At least you can count how many times you fail.
Yeah.
Just kidding.
Cool. 1 out of 9, 1 out of 9, 1 out of 9.
Oh, 2 out of 9.
What's this? 6 out of
27 divided by 3.
2 out of 9.
2 out of 9. 2 out of 9.
Oh, we're just the math teachers today, aren't we?
Alright, man, you got this, mate, for sure.
1 green, 2 red, 1 out of 9, 1 out of 27, 1
Okay.
out of 9, 1 out of 9. 7.
Yeah.
Cool. Beautiful. Alright. Now I'm going to say, I just want to know what's the probability of getting 2 reds. Exactly 2 reds.
Maybe 1 out of 10? Or is that still
No, 2 out of
a
9.
thing? Oh no, so that would be 6 out of 27, which is...
Are we not allowed to get 3 reds?
Is 3 reds 2 reds?
Guess not. We'll go
2 out of 9.
Okay. So if we go through, reds, not enough. Reds, yes.
Wait,
Reds,
you
reds.
still get
That,
you still get
That's it?
2 reds out of the 3 reds though. I must.
so this is where we have to be really careful about what we're saying.
If there's no rule stating we can't have 3 reds.
Okay, that's, here's the issue. That's 10 out of 27.
7 out of. Isn't that 7 out of 27?
That's not 10 out of 27.
Equal to or greater than 2 reds, right?
Yes, it is.
Yeah, 7 out of 27.
Oh,
Coco?
Yeah.
Just add the numbers.
Dane,
Dane, just add the numbers up, like that are next to the letters.
I added 3. Don't worry.
You added 3 or you added 2?
I just added 3.
Ah. So you got 5 out of 9, or did you get?
I got 10 out of 27.
Seek. Greater than or equal to 1b, given that 1g
This seat,
has
this seat
occurred.
sucks on light outside, showing you only where you're running.
Okay, so you get 1g.
I get,
Yeah, kind of.
Which one? From this one? Or this one?
I think it's that one.
The third?
Wait,
1g.
no, it's the middle one.
Middle one.
It's the middle one, but not where you stood.
That better?
Yeah.
Okay.
Let me just click all the notifications and write somewhere else.
Nice to have something like, oh, speak like that, don't mind. Anyway. You guys can all see happily though?
Yeah.
Yeah.
Cool, alright. Any thoughts?
Yeah, many.
Okay, can we narrow it down to a starting thought?
Is that 12 3/4?
That's 3/4, we've got a half.
Oh, no.
19 out of 20, no.
I'm
Get
not
in 1G.
Okay, might it be a good idea to try and simplify this wherever we can?
No, we got this.
We got this? Okay, we'll do it the hard way and then we'll do it the easy way.
I said one green.
Trial and error. Trial and error.
That one, that one, instinct, right? One, nothing more.
I get 12.
You're
Oh,
12
no, wait, that's not one grade.
12 out of 27.
I got
12 out of
27.
27, 19 out of 27.
I have 9 on 27 divided by